Today we've got 11 marks, comes in 4 different parts. If you're on hardcore mode, then try and find the expansion of f of x without any hints. If not, then we'll follow A and B and get to the answer that way. Now it tells us that f of x can be expressed in the form A over this plus B over this plus C over this. So you should recognise that as partial fractions. If that doesn't seem familiar, then make sure that you know there should be a squared term and a singular term for the bracket that's squared here. Otherwise the partial fractions just won't work. So over here, I will set this equal to the form that's given. Remember, you're not always going to be given the form, so it's important to be able to come up with it yourself. Although in this question we get it, so that's kind of nice. For a partial fractions question, we want to get rid of these denominators some way. So what we're going to do is we're going to times by this denominator everywhere. So we're times by it here, times by it here, times by it here, and times by it here. If we times by it on the left-hand side, then it's simply going to disappear because you're timesing and dividing by the same thing. On the right-hand side, imagine we times this by 5x plus 2. Well, it's going to cancel out because the one's there. But there's another one. There's another one which cannot be cancelled out. And then the 1 minus 2x, I don't see that over here, so that's not going to cancel out either. What are we going to get when we times this denominator by this term with b in? Well, this is a squared term now, so that squared term is going to times and divide, cancel out completely, but the 1 minus 2x is going to stick around. And then finally with the c, the 1 minus 2x is the same denominator now, so what's going to be left, what's not going to divide, what's not going to cancel, it's the 5x plus 2 squared. Now from here, what we want to do is we want to find a value of x that we can sub in everywhere it says x that will help us find the values of a and b and c. Even though it's not explicitly a hint, there is something in the question that may help you decide the values of x. So we're told that x cannot be a half, and we're told that x cannot be minus 2 over 5. The reason for that is otherwise the denominator would be 0. That's not good. However, because they write that, that gives you the indication that those are actually the values of x that we want. So let's take the half. If x were a half, then what are we going to get? 50 over 4 plus 19 plus 9 is equal to a times, that's going to be 5 over 2 plus 2, but this is going to be 1 minus 2 halves, which is 0. So essentially that bracket will cancel out the whole of the a terms and everything with it. When we times it by b, 1 minus 2 lots of a half, that's also 0. So again, they will cancel each other out. And this is the really great thing about choosing that half, or choosing the value well, you'll be able to cancel out as much as possible. At the end here, what we're going to get, if x is a half, this is going to be 5 over 2 plus 2 and then squared. Now we can start to simplify things. So we're going to get 25 over 2 plus 28, and that's going to be equal to c lots of 9 over 2 squared, or 81 over 4. Then put these two together. 81s will cancel, times by the 4, we're going to get c is equal to 2, which is quite a nice answer. In order to get the value of b, which part AI is looking for, we want to find the other value. So that is x equals minus 2 over 5. The method for this one is the same, so I'll speed through it, see if you can get the same value for b as I do. So as long as you don't accidentally make the negative mistake that I did, you should hopefully find that b is equal to 1. And then we can move on to part A-I, which is asking for the value of a. Well, we've tried the value a half. We've tried the value minus 2 over 5 given in the question. There's no other values there to try. So what values of x can we choose? Well, it doesn't matter. It literally does not matter what you try as long as they are different from what you've already done. What's the easiest value? Well, to me, it's going to be x is equal to 0. But you could use x equals 1, you could use x equals minus 1, you could use x equals 22/7, you could use x equals pi. It really doesn't matter. It will all come out anyway. It will all get to the same answer. But 0 is going to be the easiest one here because 50 times 0 is 0. 38 times 0 is 0. So the only thing left is going to be 9. And then on the other hand side, we can simply get rid of those x terms because it's 5 times 0. So we're going to have a times by 2 times by 1 plus b times by 1 plus c times by 2 squared, or 4. So it's simplified down a heck of a lot by using the value x equals 0, where if we use the value x equals 1, then you would have had to put a bit more thought into it. But the great thing is here, we now know what b is. It's 1, so I'll add 1. And we know what c is. It's 2. So that means if we subtract this, 1 plus 8 is 9. 9 subtract 9 is 0. So we get a is equal to 0, which is actually what the question wanted. It wasn't saying find the value of a. No, show that a equals 0. So a equals 0 as required. And after part A, of course, comes part B. And this is the part where we actually have to find the binomial expansion of f of x using partial fractions that we did in part A. If this question were all in one go, then you'd have to know to use partial fractions because it's each of these fractions here that can be written as a binomial expansion. You can't write this original as a binomial expansion just straight away. You have to split it up first, do each individually, and then put them together at the end. So let's see how we're going to do that. So I've written f of x in the form given in part A, but with a being 0, so that means I've just got rid of it. So we've got 1 over 5x plus 2 squared and 2 over 1 minus 2x. What we've got to realise is that that's not in the form for binomial expansion, so we have to use our laws of powers to write this as 5x plus 2 to the power of minus 2 plus 2 lots of 1 minus 2x to the power of minus 1. If I quickly get up the formula now, then you can see that this formula is in the form something plus x to the power of n. And now we've written our formulas as a bracket to the power of n. It's not quite in the right form, it's not quite 1 plus yet, but we'll get to that. For starters, I'll do this one because this has 1 and then it's got some term next to it. So to use the formula, what we're going to do, 1 minus 2x to the power of minus 1. It starts with a 1. That's what the formula says. That's what the formula says here at the bottom. Starts with a 1. Always starts with a 1. Next up is nx. Nx means take the n, which is the power, which is minus 1, and times it by the x. But the x isn't x. X is just a placeholder. The x is whatever is next to the 1. In our case, the x is minus 2x. So nx is minus 1, the power, times by minus 2x, which is the x bit. Then we're going to continue. We're going to do minus 1, which is the n, which is here. Then we're going to take 1 away, which is minus 2. We're going to divide by, I prefer to do 2 factorial, but 1 times 2 is exactly the same. And then we're going to take the x bit. Again, it's not x, but it's minus 2x in our case. And we're going to square that because that's what it tells us to do down here. Okay, reading the question again, we only care about the terms up until x squared. So you know what? I'm going to stop there. Let's at least expand and simplify though. We're going to get 1 plus 2x. The 2 is going to cancel out with the 2. The minuses are going to cancel out with each other. The minus squared is going to make a positive, and the 2 squared is going to make 4. So the full binomial expansion for 1 minus 2x to the power of minus 1 is 1 plus 2x plus 4x squared. We'll now do a similar thing for 2 plus 5x to the power of minus 2. Now I've swapped the 2 and the 5 around, and that's because then it looks a bit more like the original formula. The original formula down here starts with a 1 plus, so it's a number plus. So I'll put the number at the front, so it's looking similar. But of course, it's got a 2, not a 1. What are we going to do with that? Well, why don't we take out a factor of 2? Why don't we write it like this? 2 plus 5x is the same as 2 times 1 plus 2 times 5x over 2. So essentially I've divided both terms by 2 and chucked a 2 on the outside of the bracket. That represents 2 plus 5x. 2 plus 5x is all to the power, nice big brackets please, all to the power of minus 2. And that's very important, and that's a very common cause of issues because sometimes that 2 is just on the outside, which would be wrong. If it's on the inside, then we have to do 2 to the power, 2 to the power of minus 2, followed by 1 plus 5x over 2 to the power of minus 2, using our laws of indices. Now from here, if you know your powers, minus 2 represents 1 divided by something squared. So this is 1 divided by 2 squared, or 1/4. And then we can expand this. Why can we expand it now and not before? Because it starts with a 1, so we're all happy. What's the binomial expansion going to start with? It's a 1. Said it before, said it again, it's always going to be 1. And then it's nx. N is now the power, which is minus 2. Before it was minus 1. And then the x, again, it's not x, it's 5x over 2. It's the bit next to the 1. So in our case, the x is 5x over 2. And then we do the next term. So we start with n, and then we do n minus 1. So minus 2, and then times by minus 3. We divide it by 2 factorial, or 2 times 1. And then we take the x squared, but it's not x. In our case, it's 5x over 2, and we square it. There will be more terms. There will be a cube term. There will be a power to the 4. There will be all of those terms, but we don't need them. So I'm going to stop there, and we're going to simplify. So we're going to get 1. This time it's going to be minus 5x. This time this 2 will cancel out with this 2. This negative will cancel out with this negative, so we're going to have a plus. And then it's 3 times 5 squared, 75 over 2 squared, 4x squared, like that. And then to finally finish off, we can times this all by a quarter. 1/4 minus 5/4 x plus 75 over 16 x squared. Not quite as nice as the first one. Okay, we're almost there. We've almost got all our marks, but we need the binomial expansion of f of x. Well, look at f of x. It's written as this plus this. But this expansion, we know it's down here. And this expansion, we know it's right here. So all we have to do is add this expansion to 2 lots of this expansion, because there's that sneaky 2 there, and then we'll have our answer. So f of x will be equal to, take the expansion of 5x plus 2, which is this one. So 1/4 minus 5 over 4x plus 75 over 16x squared. And then I'm going to plus 2 lots of the second expansion, this expansion here, which is 1 plus 2x plus 4x squared. And once I expand that out, to get 1/4 minus 5 over 4x plus 75 over 16x squared plus 2 plus 4x plus 8x squared. And then once I simplify that, and we get 9 over 4 plus 11 over 4x plus 203x squared divided by 16. It says where p and q and r are simplified fractions to be found. So p will be 9 over 4, q will be 11 over 4, and r will be 203 over 16. Okie doke, let's finish off with part BII. Somehow the trickiest part of the question, even though it's only worth 1 mark. It's when are the values of x valid for this expansion? Well, we've got the fact in the formula book. It says down here that the modulus of x is less than 1. Most students don't read that. They look at the formula and forget that that bit exists. So that says the bit that's x, which doesn't have to be x, the bit that next to the 1 is less than 1. So in our case, if we're thinking about the bracket 2 plus 5x to the minus 2, then that's not got a 1. So we think about instead the bracket 1 plus 5x over 2 to the power of minus 2 with the quarter on the outside like we saw before. Now it's next to the 1. Now we can say that the x bit, the bit next to the 1, 5x over 2, is less than 1 as per the formula. You can rearrange this if you want. It looks a bit neater, I suppose, if you times by 2 and divide by 5, but you'll be fine either way. We've also got another sequence though, haven't we? We've got 1 minus 2x to the power of minus 1. It's already in the right form this time. Take the x bit. I'm going to ignore the negative because it's a modulus. It makes everything positive, so there's no need to put it in. Take the x bit, as per the formula, make it less than 1. Again, if we really want to make it neater, we can say modulus of x is less than a half. We seem to have two answers though. Which one of these is going to be correct? There's only one correct answer here. And it's going to be this one. Try that again. This one. The reason is that's a smaller range. For example, if you take the value 0.45, that works for this expansion because it's less than a half, but it doesn't work for this expansion because it's not less than 0.4. So when you've got multiple, maybe 2, maybe 3 different validities, then we want to take the smallest one. So that's the answer to part B double I. And that's it for 11 marks. Well, there you have it, another question complete. If you're looking for more practice, try these 2 questions. If you need some hints, feel free to leave a comment below.